Welcome back to Revise and Resubmit, the podcast that takes, those really dense academic papers and makes them surprisingly interesting. I'm Pavlov.
And I'm Nikita.
Today we're getting into something that's really shaking out how research gets done. Generative AI, or GenAI. We're specifically looking at how it's being used and how it should be used effectively and responsibly in surveys and experiments. And we're basing this on some key source material you've shared with us.
That's right. It's a rapidly evolving area.
Definitely.
Yeah.
Now, before we jump in, we need to be really clear about something important. This conversation, it's built on a summary, an AI-generated summary, actually, from a specific academic article.
Which is interesting in itself, using the tool to discuss the tool.
It is, but here's the thing. These summaries, they can give you a quick overview, maybe the gist, but we really want to emphasize this.
Yep.
There's no substitute for deep reading.
Absolutely.
Engaging directly with the original, thoughtfully crafted work. That's where the real understanding, the wisdom, the empathy, the human stuff actually happens. These aren't things AI can optimize. They're things we live and develop ourselves through that deeper engagement.
You really can't shortcut that process.
Exactly. So whether you listen to us regularly or this is your first time, we really, really urge you, find the time to read the original article. It's called New Tools, New Rules, a practical guide to effective and responsible GenAI use for surveys and experiments research. It was published here, 2025, by Blanchard and colleagues in the Journal of Marketing, a top-tier FT50 journal.
It's a fantastic piece, really foundational for researchers trying to navigate this.
It is. It has a level of nuance and detail that, frankly, no summary can ever capture. So our mission today is to unpack the basics of GenAI, get a handle on what it can do, but just as importantly, what it can't do, its limitations.
Which are significant.
Very. And explore how researchers can use it well, responsibly, through the whole research life cycle. From lit reviews right through to analyzing the data, we're pulling the main ideas straight from that source material.
And the core tension, as the article highlights, is that these tools feel intuitive, easy to use.
Right, like chatting with someone.
Exactly. But that hides a lot of complexity underneath. And researchers really need to understand that complexity to use these tools properly and, crucially, to avoid some pretty serious pitfalls.
Okay, so let's start there. Under the hood. You mentioned these systems feel like chatting, but at their core are large language models, LLMs. Things like ChatGPT, Claude, Gemini. They all run on LLMs, right?
That's the engine, yes. At the heart of these GenAI systems is an LLM.
So what is an LLM, fundamentally? You said its goal is just predicting the next token. That sounds almost too simple.
It sounds simple, but the scale makes it incredibly complex. Think of an LLM as a vast layered neural network. It's been trained on absolutely enormous data sets, text from the internet, books, articles, code, just massive amounts of text data.
Billions of words, trillions.
Billions, even trillions of tokens, yeah. And during that training, its single primary objective is to learn to predict the next token. Think of the token usually as a word or part of a word in a sequence. Yeah. And by doing just that over and over again on this huge data set with billions of internal parameters to adjust, the model starts to internalize grammar, syntax, different writing styles, factual associations.
Associations, not necessarily facts.
Well, patterns that look like facts. It learns relationships between words and concepts based purely on how they appear together in the training data. It learns meaning from context.
So how does it get from, say, a web page text to predicting the next word? Walk us through that process.
Okay, the source breaks it down nicely. First is data gathering and preparation. You collect all that diverse text. Then comes tokenization.
Breaking it into those tokens.
Right, chopping the raw text into smaller units. And importantly, these aren't always whole words. Often they're subwords. The article uses a great example. Limited time offer on unbelievably good deals.
Okay.
A tokenizer might break that down into tokens like limited. See how unbelievably got split.
Ah, right. Unbelievably. Why do that?
It's super useful. It lets the model handle words it hasn't seen before, or rare words, or even misspellings. If it understands the parts on or ably, it can make sense of new combinations. It learns morphology, basically.
Okay, makes sense. So you have these tokens. What's next? Numbers.
Exactly. Each unique token gets an ID number. Then comes token embedding. This is where the magic starts, sort of. Each token ID is mapped to a vector, a long list of numbers in a high-dimensional space.
High-dimensional? Like how high?
Really high. The source mentions examples like 4,096 dimensions. So the token for limited becomes a specific list of 4,096 numbers, and Apple becomes a different list of 4,096 numbers. Think of it like a giant lookup table, the embedding matrix.
And these number lists, these vectors already capture meaning at this stage. Like similar words have similar number lists.
That's a key point. The source flags to clear up misconceptions. No, initially, these vectors are just random numbers. They are completely meaningless placeholders. They only start to capture linguistic patterns, semantic relationships like, the classic king minus man plus woman equals queen idea from earlier research through the training process. The meaning emerges from seeing how words are used in context billions of times.
Got it. So the meaning is learned during training. Tell us about that training process.
Right. So the goal is predicting the next token based on the preceding ones, the context. And context is everything in language, right? Model means one thing in research, another in fashion.
Sure.
The model learns this by being shown billions of text sequences. The token embeddings for a sequence go into the network's layers. And a crucial mechanism here is self-attention.
Self-attention, what does that do?
It's really clever. It allows the model, when it's processing one token, to dynamically figure out how relevant every other token in the input sequence is to understanding that specific token.
So back to limited time offer on unbelievably good deals.
Yeah. When the model processes deals, self-attention helps it understand that unbelievably and good are really important modifiers. When it looks at offer, it pays attention to limited time.
And it learns these connections automatically.
It infers them. It's not explicitly told this modifies that. It learns that paying attention to certain words helps it make better predictions for the next token. It gets feedback on its prediction errors and uses that feedback to adjust all its internal connections, the weights in its layers, the embeddings themselves, through a process called backpropagation.
And it does this adjustment millions, billions of times.
Billions of times, across countless examples. Gradually, it gets better and better at understanding context and predicting what comes next. As the input goes through layers, it creates richer, contextualized representations for each token.
Okay. So after all that processing, how does it actually make the prediction?
So using the final representation of the sequence so far, the model generates a probability distribution over its entire vocabulary for what the next token could be.
A probability for every single possible next token.
Yeah. For thousands, maybe tens of thousands of tokens, given limited time offer on, it might assign, say, a 40% probability to unbelievably, 20% to amazing, 10% to R, and tiny probabilities to words that don't make sense there.
Okay, so it has probabilities. How does it pick just one? Does it always pick the most likely one?
It could just pick the highest probability. That's called greedy decoding. But usually, to get more interesting and varied text, GenAI systems use sampling. They sample from that probability distribution.
Meaning less likely words get a chance.
Exactly. And you can control how random or creative this sampling is using parameters. The main one is temperature. Lower temperature makes it stick to high probability choices, more focused, predictable text. Higher temperature increases the chance of picking less likely tokens, more diverse, sometimes surprising or creative output.
I've seen that setting.
Yeah. There are also other methods like top K or top sampling that tweak the sampling pool. The point is, there's a choice function that turns the probabilities into a single chosen token.
Well, once it picks that token,
it adds it to the sequence. So now the input sequence is one token longer. Then it repeats the whole process, predicts the probabilities for the next token based on the new, longer sequence, samples one, adds it, and keeps going.
One token at a time.
One token at a time, until it generates a special stop token or hits a length limit. That's how it builds up the response, like, consider using. Limited time offer on our new product. Buy now and save 20%, token by token.
And this generation phase where it's creating text for me, that's after training is done.
Yes, that's called inference. And critically, during inference, the model's parameters, all those connections it learned, are fixed. It's not learning anything new from your prompt or its own generated text in that moment.
So my prompt doesn't change the model itself?
No. Prompting just guides the model on which parts of its fixed knowledge to access and how to structure the output. It's selecting from what it already knows based on the context you provide.
You also mentioned the context window. That limits how much text it can look at.
Exactly. It's the maximum number of tokens the model can process at once. Early models had small windows, like 1,000 tokens. They'd lose track in long conversations or documents.
But they're getting bigger.
Much bigger. The source mentions GPT 3.5 handling around 4,000 tokens, and newer models like GPT 4o up to 128,000 tokens. That's huge. It allows them to handle much longer texts, maintain coherence over longer interactions.
Okay. And the other key thing you mentioned was its stateless nature.
Yes. For the bare LLM itself, each interaction is fresh. Unless the previous conversation turns or relevant text are explicitly included in the current prompt, it has no memory of what came before.
So the chat interface is actually feeding the history back in each time.
Pretty much, yeah. It has to manage that state externally, usually by including recent turns within the context window for the next prediction. The LLM itself doesn't inherently remember past interactions session to session.
Okay, this gives a much clearer picture of the core engine. So based on this architecture and training, the source summarizes some key limitations, right? Table 1, I think.
Yes, and understanding these constraints is absolutely vital for using GenAI responsibly in research. Let's run through them.
Go for it.
First, predetermined corpora. Their knowledge is frozen in time based on when their training data was collected. They don't know recent events or findings.
Okay, the knowledge cutoff.
Right. Second, no retrieval capability. This is huge. LLMs generate text that looks like retrieved information, but they don't actually look things up in a database. They reconstruct based on patterns.
This is where hallucinations come from.
Primarily, yes. They might generate a citation that looks right because the author, topic, and journal often appear together, but it's fabricated. They aren't retrieving a fact, they're predicting the most likely sequence.
Got it. What else?
Text-only inputs-outputs, fundamentally. They need help, external tools to handle images, tables, audio. Also, limited input-output size. Even with big context windows, there are still limits. Long text can get cut off, output length is limited.
And the memory thing.
Lack of persistent memory. They forget past interactions unless explicitly reminded in the prompt. Makes complex, multi-step tasks tricky.
Right.
Then a really big one for research. Optimized for plausibility over accuracy. Their goal is fluent, coherent text, not necessarily true text. This is the engine driving hallucinations. They can sound totally convincing while being factually wrong.
That's worrying.
It is. Also, probabilistic output. Because of sampling, you can get different outputs even for the same prompt. That makes exact reproducibility hard for some tasks.
Coding text.
Exactly. And finally, inability to run code. A bare LLM can write code because it's seen lots of code, but it can't execute it or check if it works or gives the right answer. It might generate code that looks right, but is flawed.
Okay, those are some serious limitations inherent to the core LLM, but you said we usually interact with a broader GenAI system.
Yeah.
How do these systems try to overcome these limits?
Right. Think of the LLM as the brain, but the system builds around it. Figure 1 in the source shows this conceptually. These systems add components. Well, for handling non-text data, they add input processing. A key part is often a document processor. When you upload a PDF or spreadsheet, this component extracts the text, maybe breaks it into chunks, and turns it into embeddings the LLM can work with.
And this doesn't retrain the LLM.
No, crucially, it doesn't change the LLM's core knowledge. It just makes the content of your document available to be temporarily added to the LLM's context window when you ask questions about that document.
So it grounds the LLM in the specific text I provided.
Exactly. It gives it immediate context. Systems might also have multimodal capabilities to translate images or audio into something the LLM can process, or vice versa.
What about the knowledge cutoff and the hallucination problem?
That's often addressed using retrieval mechanisms, typically retrieval augmented generation, or RAG.
Raggy, how does that work?
The system takes your query, searches external sources like the web or specific databases, finds relevant snippets of information, and then feeds both your original query and this retrieved information into the LLM's prompt.
Ah, so it gives the LLM fresh external facts to work with.
Yes. It provides current or specific context. This can definitely help reduce hallucinations and get around the knowledge cutoff. But the source is clear. RAG helps, but it doesn't eliminate hallucinations. The LLM is still the one synthesizing the final answer, and it can still misinterpret or misrepresent the retrieved info.
Okay, so it helps ground it, but isn't foolproof.
Yeah.
And the inability to run code.
That's overcome by integrating a code environment. This is a big one. The GenAI system connects the LLM to an external code interpreter, often Python.
So the LLM writes the code, and this environment runs it.
Precisely. You ask for an analysis. The LLM generates the Python code needed. The system sends that code to the execution environment. The code runs, the results come back to the system, and the LLM then explains those results to you in plain language.
That bridges a huge gap for quantitative tasks.
A massive gap. It allows the system to actually perform calculations, run stats, analyze data by leveraging the LLM's code writing ability and the interpreter's execution ability.
Okay, so these systems layer on capabilities. How do researchers actually access them? What are the main options and trade-offs? Table 2 in the source covers this.
Yes, Table 2 lays out the main access modes. The most common starting point is probably the web-based chat interfaces.
Like the ChatGPT website or Claude Gemini?
Exactly. Super easy to use, very conversational, great for brainstorming, getting summaries, drafting text, maybe analyzing an uploaded document if the interface supports it.
And they often bundle many of these features, like search and code execution.
Often, yes. The best ones integrate RAG, document upload, sometimes image input, and code execution directly into the chat. The big advantage is accessibility.
What are the downsides for serious research?
Reproducibility can be harder than with Kind. It's less scalable for processing, say, thousands of survey responses. Integration with specialized stat software is limited. And you often don't know the exact LLM version being used or how it might change without notice.
And privacy.
That's a major concern with the free public web interfaces. Your inputs might be stored, potentially used for future model training. For research data, especially sensitive data, you really need enterprise accounts or specific agreements guaranteeing privacy.
Okay. What if I need more control, reproducibility, or I need to automate a task over lots of data?
Then you'd likely use API-based access. This means writing code, usually Python or R, to send queries directly to the model provider servers and get responses back programmatically.
So I'm scripting the interaction.
Exactly. Table 3 gives a little R code example concept. You set your API key, choose the model, define your prompt, maybe set parameters like temperature, send it off, get the text back.
What's this best for?
It's ideal for repetitive tasks on many items, like coding thousands of open-ended responses. It makes workflows reproducible because your script documents exactly what you did. Great for large-scale text processing or integrating GenAI into existing analysis pipelines.
Limitation.
APIs usually don't have the nice web interface features built in, no integrated web search, limited file type inputs, usually just text, no interactive chat feel. And API calls are typically stateless, so you have to manage conversation history yourself if needed. Requires some programming skill too.
What about data privacy through APIs?
You have to check the provider's terms carefully. Some API usage might still be logged or potentially used for training, depending on the provider and the specific service tier. It's not automatically private just because it's an API.
Okay, so if privacy is the absolute top priority, especially with sensitive participant data,
then the best route, according to the source, is local model installation. You download an open source LLM and run it entirely on your own computer or your institution's secure servers. Software like Llama helps manage this.
so the data literally never leaves my control.
Correct. Total data privacy. This is the gold standard for highly sensitive research, like analyzing confidential interview transcripts or working with proprietary corporate data. Plus, you can sometimes fine-tune the model on your own data and it works offline.
Downsides.
Computational cost. Running the big, powerful models locally needs serious hardware, often high-end GPUs. Smaller models can run on laptops, but might be less capable. And you usually don't get the integrated web search, document processing, or code execution environments unless you build those connections yourself.
But for security, it's the clear winner.
Unquestionably. If data cannot leave your environment, local models are the way to go.
All right, that maps out the landscape really well. The core LLM, the system enhancements, the access methods. Now let's get practical. How does this play out across the stages of research? Let's follow the source's structure, maybe using their unattractive produce example.
Yeah.
Stage 1, interacting with the literature.
Okay, this seems like a natural fit for GenAI, right? Summarizing papers, finding connections.
Yeah, potentially huge time saver.
It can be great for exploration, quickly getting the lay of the land, identifying themes, finding related concepts. RAG features help it pull recent info. But the big risk we keep coming back to is accuracy.
Hallucinations again.
Yes. They're not optimized for factual precision. The source gives that example of finding a paper by Duani et al. On ugly food. The AI got the authors and topic right, but hallucinated the journal name said Food Quality and Preference instead of Journal of Cleaner Production.
Why? Just because those things often peer together.
Exactly. It predicted the most plausible combination based on its training data. It didn't verify the fact.
So how do you use it safely for lit review?
You need to ground it. Using RAG systems with web search helps. When they reran that query with web search on, it found the correct citation.
So our RAG fixed it.
It found the citation, yes. But the source notes that even then, when asked for a summary and links, the system sometimes provided links to a different paper by the same authors or summarized the wrong one. So our RAG reduces errors but doesn't eliminate them. Best practice, Always trace the sources. Verify citations and key claims yourself.
What about digging into one specific paper I already have?
That's where document upload is key. Upload the PDF to a system that supports it. This grounds the AI's answers in the actual text of that paper, massively reducing hallucination risk for questions about that specific document.
Like the Grussel at a poll.
Yeah.
Produced paper example. They uploaded it.
Yes. And asked for a table summarizing the studies, Table 4. With the document uploaded, the AI generated a pretty useful table, much better than it could have done from memory.
But still not perfect.
Still not perfect. The source points out errors even in that table generated from the uploaded PDF. Mixed up an IV and a moderator for one study, missed a mediator. It shows that even with the text right there, the AI's extraction and interpretation aren't always flawless.
Okay, so summarizing best practices for literature work.
For broad exploration, okay, but be skeptical. For accuracy on specific facts or papers, use REG or document upload. Document upload is generally better for analyzing a single known paper. Always verify key information and citations. Watch out for knowledge cutoffs. Be careful with uploading copyrighted material to public services due to privacy and training data concerns. Use local models or enterprise accounts if needed. And for long docs, maybe break down the task or re-upload to manage the context window.
Very clear. Let's move to stage 2, research design. This is about creating measures, stimuli, experimental procedures. How can GenAI help here?
It can be a powerful brainstorming partner. Great for generating ideas for survey items, scale development, writing text vignettes for experiments, even creating images with multimodal systems. It leverages its pattern recognition to generate lots of variations quickly.
So if I need a scale for, say, perceived uniqueness of a product,
You could ask GenAI for item suggestions, but here's where the lack of theoretical understanding bites. The source uses the produce visual attractiveness example. Ask for items without defining the term carefully.
and you get
Plausible but flawed items. Like, this produce looks visually appealing, the color is vibrant, appears fresh and high quality, proud to display. They sound okay.
But what's wrong with them?
They conflate the specific construct gruel at all, defined, natural shape surface deviation, not spoilage, with general appeal, freshness, quality, even social aspects. The AI doesn't know the precise academic definition, it just pulls associated words from its training data. You get double-barreled items, overlapping concepts, huge construct validity risks.
Because it's just using common language associations, not the specific theory.
Exactly. It's statistical patterns, not deductive reasoning. The fix. Provide the operational definition in the prompt. When they gave the AI the Gruel et al. Definition, the suggested items improved dramatically. Things like resembles what I expect produce to look like, little natural variation, consistent with my mental image, much closer to the target.
So defining terms is non-negotiable.
Absolutely critical. And even then, you still need to check for errors, double-barreled items, weird phrasing. Iterative refinement helps tell the AI that item is double-barreled, fix it. But the bottom line, generating items is only step one. It doesn't replace empirical validation. You still have to test the scale properly.
What about creating experimental manipulations like vignettes or images?
Similar story. Great for generating context-rich scenarios or visuals, but the risk of introducing confounds is very high.
Confounds.
Systematic differences between your conditions that aren't the thing you meant to manipulate. The sources example. Ask for vignettes for attractive versus unattractive apples. The AI might make the attractive one flawless and shiny, and the unattractive one dull and less fresh. Now you've confounded attractiveness with freshness.
Ah, I see. And with images too.
Yes. Table 5 shows this. Ask for an unattractive apple image, and you might get a spoiled or damaged apple, not just an oddly shaped one, because unattractive often co-occurs with spoiled in its training data.
So how do they fix that for the images?
Again, providing the precise definition helped get oddly shaped but fresh apples, but for really tight control, they had to go deeper. They asked the LLM for the exact text prompts it sent to the image generator, DALE. Then they manually edited those prompts to specify only shape asymmetry while keeping freshness constant.
So you might need to get into the weeds and tweak the AI's instructions.
Sometimes, yes, especially for rigorous experimental control. GenAI is a great assistant, but you, the researcher, are responsible for ensuring the validity of the design and controlling confounds through careful prompting and refinement.
So summing up best practices for study design.
Brainstorming partner, yes. But always define constructs operationally in prompts. Don't assume it knows academic nuances. Keep distinct concepts separate. Maybe generate conditions together in one prompt for parallelism or separately for tailoring experiment. Tell it you're designing an experiment. Use its variability for stimulus sampling if appropriate. Iterate and refine based on errors. And crucially, generating stuff with AI never replaces the need to empirically validate your measures and manipulations.
Okay. Stage 3, study administration. Using AI dynamically, maybe as an interviewer.
Yeah, this opens up cool possibilities beyond static surveys. The source mentions using a GPT-powered chatbot in Qualtrics to conduct semi-structured interviews. The AI acts as the virtual research assistant.
How do you get an AI to follow an interview guide? Must be complex prompting.
Very detailed prompting. Figure 2 gives the idea. You have to define its role, the goal, the topic, constrain its behavior, only ask questions, tell it how to flow, maybe how many questions, when to introduce topics like unattractive produce, how to probe responses.
But you said prompts are suggestions, not hard rules.
Exactly the risk. An LLM might still deviate. Because it's based on patterns, if a participant goes way off topic, the AI might just follow them conversationally instead of redirecting, even if your prompt told it to stick to the guide. Its lack of perfect memory over long interactions also plays a role.
And the probabilistic output, does that cause issues here?
It can create variability. The source shows 2 slightly different AI follow-up questions to the exact same participant statement. These small variations, driven by sampling, can accumulate, meaning different participants might have slightly non-standardized experiences.
So what are the best practices if you're using AI to administer parts of a study?
First, log everything. Keep complete transcripts of every AI participant interaction. You need this for analysis, debugging prompts, checking for deviations, and transparency. Second, document AI specs meticulously. Model version, parameters, temp, seed, exact prompt text, any reinforcement prompts, exclusion rules for participants if the AI messed up. Third, ask participants about their experience, technical issues, confusion.
What if the AI is the manipulation, like different AI tones?
Then you absolutely must pre-test those prompts and use manipulation checks. Just like with human confederates. Never assume the prompt worked and the AI delivered the manipulation faithfully. You need proof.
How can you nudge the AI back on track if it drifts?
The source suggests reinforcement prompts. These are hidden messages you inject. If the participant goes off topic, you might add a hidden instruction like system steer back to produce selection. The AI sees this with the participant's text and hopefully adjusts.
Clever. And participant safety and privacy.
Crucial. Clear informed consent that they're talking to an AI, caution them about sharing overly sensitive info, and absolutely verify the provider's data use policy. Ensure participant responses won't be used for model training, especially with confidential data. Local models or enterprise accounts are safest here.
Okay, final stage, data analysis and interpretation. Coding, stats.
Big potential here. We're speeding things up, generating code, helping novice programmers.
But can I just give it data and ask for a t-test result?
Not with a bare LLM. The source showed it just makes up plausible looking numbers, means p-values that are totally wrong. It's simulating output, not calculating. Statistical hallucination.
Right, so you need the system with the code environment.
Yes, that's the key. You upload data, like a CSV. Ask for the t-test. The LLM writes Python code to do the t-tests. The system executes that code on your data. It gets the real results back. Then the LLM presents those correct results to you.
So it uses the LLM to write code and the environment to run it.
Exactly. It overcomes the calculation limitation. Powerful for interacting with data via natural language. But still, you need to check the generated code. Is it doing the right test? Handling options correctly. And uploads are often temporary.
So the recommendation for stats analysis?
Use it for exploratory analysis, checking data, summaries, visualization ideas. Do not run your final confirmatory analyses inside the GenAI system. Extract the code, verify it, and run it in your trusted stats software, R, SPSS, etc., for the final paper.
What about coding qualitative data, like open-ended responses?
Huge potential for scale, but pitfalls too. Don't just paste loads of responses into one chat context limits, loses independence. Don't do them one by one in new chats, too slow.
So what works better?
2 main approaches from the source. First, sequential API-based coding. Write a script. Send each response individually to the API with standard instructions. Rate perceived risk 1 to 5. Treats each response independently, like separate coders. Downside? Probabilistic output means potential variability, less transparency on why a score was given. Second, file upload with code execution. Upload your whole dataset, CSV, to a chat system with code execution. The LLM helps generate a custom coding dictionary rules in Python based on your data. Then it applies those rules systematically using the code environment. More transparent, you see the rules code, data adaptive. But maybe less nuanced than the API approach for each response, as it becomes more like applying a fixed, though custom dictionary.
How does this compare to something like LAWC?
LAWC is a fixed dictionary. LLMs understand context. An LLM might see that looks weird as implying risk in context, even if weird isn't in a risk dictionary. LLMs capture nuance beyond just word counting.
Okay, so best practices for analysis and coding overall.
Exploratory analysis, yes. Confirmatory stats, no run code elsewhere. For coding, use structured prompting, role task format, few-shot examples, to improve reliability. But the absolute biggest point,
Validation.
empirical validation. A good prompt is not enough. Just because the AI output looks okay doesn't mean it's validly measuring your construct. The ease of tweaking prompts creates huge researcher degrees of freedom risks fiddling until you get the result you want. That kills credibility.
So how do you validate AI coded measures rigorously?
The source offers specific strategies, figure 3, depending on the ground truth you're aiming for. Is it the participant's internal state, an observer's judgment? Predicting an outcome.
Okay, walk us through those. Participants' internal state.
Use holdout self-reports. Collect text and self-report measures in sample 1. Use sample 1 to develop your AI coding protocol, prompts, settings to predict the self-reports. Then, freeze the protocol, pre-register it, and collect a new sample 2. Validate on sample 2. Need that truly separate sample for confirmatory claims.
Observer's interpretation. Like coding sentiment or tone?
Use holdout judge ratings. Develop the AI protocol. Freeze it and the AI scores. Pre-register, then get human judges to rate a separate dataset or subset. Compare AI scores to human ratings, just like traditional content validation.
Predicting an objective outcome, like purchase behavior.
Use holdout outcome. Split your data, train validate, before looking at the outcome. Use the train set with outcome data to develop the AI protocol to predict the outcome. Finalize the protocol. Apply it to the validate set without the outcome, then add the outcome to the validate set and see how well it predicts on this unseen data. Follows the spirit of pre-registration by separating development from testing. And remember, prediction doesn't automatically equal construct validity.
These validation strategies seem crucial for maintaining rigor.
Absolutely essential. They acknowledge practical limits, maybe you use subsets,
Yep.
but the principle is key. AI doesn't get a free pass on validation just because it's fast.
Wow. Okay, that really covers the landscape described in the article. The tech, the systems, the access, and the opportunities and critical risks at each research stage. It's clear these new tools definitely come with some very important new rules.
For sure. The takeaway is that you can't just treat GenAI as a magic black box, especially in research. You have to understand, at least conceptually, how it works, where its limits are, the probabilistic nature, the lack of real understanding, and how the different systems try to address those limits.
And that responsibility piece is huge. Careful prompting, checking manipulations, and especially that empirical validation for anything AI generated that functions as a measure.
The potential is there to really accelerate research, but only if it's done thoughtfully and rigorously, following these emerging best practices.
Which brings us to a final thought for you, the listener, to maybe chew on. If these AI tools are built for plausibility, for pattern matching, sometimes at the expense of factual accuracy, what happens as we rely on them more and more? Does the ease of generating perfectly plausible text or code subtly shift our own focus away from the harder work? Away from digging for truth, grappling with nuance, validating findings empirically, all in the name of speed and efficiency? How do we keep our own standards high when the tools make plausible shortcuts so easy?
It really puts the onus back on the human researcher, doesn't it? To be the critical thinker, the validator, the interpreter. The tools are powerful assistants, but they don't replace that core human role in the scientific process.
Well said. Thanks for joining us on this deep dive into GenAI in research. We hope it's given you a clear view of the tools and the rules. And seriously, do check out that original Blanchard et al. Article in the Journal of Marketing. It's worth your time. And don't forget to subscribe to Revise and Resubmit on Spotify and Apple Podcasts. Until next time, keep those minds curious, keep questioning, and keep revising and resubmitting.
রিভাইজ অ্যান্ড রিসাবমিটে স্বাগতম। আমি প্যাভলভ।
আর আমি নিকিতা।
শুরুতেই একটা কথা বলে নেওয়া খুব দরকারি মনে করছি। আমাদের আজকের এই আলোচনাটা এটা কিন্তু একটা লার্জ ল্যাঙ্গুয়েজ মডেল বা LLM দিয়ে তৈরি করা একটা গবেষণা প্রবন্ধের সারসংক্ষেপ। দেখুন, কোনো কিছু গভীরভাবে পড়া সেটা জ্ঞান বাড়ায়, সহানুভূতি জাগায়, মানবিক বোধ তৈরি করে। এগুলো তো অপটিমাইজ করার জিনিস না, এগুলো আসলে যাপন করতে হয়। তাই শ্রোতাদের কাছে আমাদের অনুরোধ থাকবে, আপনারা এই চ্যানেল সাবস্ক্রাইব করুন বা নাই করুন, প্লিজ একটু সময় বের করে মূল প্রবন্ধটা পড়বেন। লেখাটা কিন্তু খুবই গুরুত্বপূর্ণ একটা FT50 তালিকাভুক্ত জার্নালে বেরিয়েছে। লিঙ্কটা শো নোটসে দেওয়া আছে। আচ্ছা, এবার আজকের আলোচনায় আসি। বিষয়বস্তু হলো গবেষণা, বিশেষ করে সার্ভে আর এক্সপেরিমেন্টের ক্ষেত্রে এই যে জেনারেটিভ AI GenAI আর LLM এর ব্যবহার বাড়ছে সেটা নিয়ে আমরা ব্ল্যানচার্ড আর তার সহকর্মীদের লেখা একটা গবেষণা প্রবন্ধ থেকে বোঝার চেষ্টা করব এর ভালো মন্দ দিকগুলো। মূল লক্ষ্য হলো এই প্রযুক্তির সম্ভাবনা কোথায় আর ঝুঁকিগুলোই বা কী। কারণ ChatGPTর মতো টুলগুলো তো হু হু করে গবেষণার জগতে ঢুকে পড়ছে, কিন্তু অনেকেই হয়তো এর আসল কার্যপদ্ধতি পুরোপুরি না জেনেই ব্যবহার করছেন, তাই না?
একদম ঠিক বলেছেন। এই LLM গুলো আসলে কি করে, ওরা তো বিশাল টেক্সট ডেটা দেখে দেখে শেখে। কোন শব্দের পর কোন শব্দ আসবে সেই প্যাটার্নটা ধরে ফেলে। ওদের কিন্তু নিজস্ব কোনো বোধ বা জ্ঞান তৈরি হয় না সেভাবে। আর কিছু সীমাবদ্ধতাও আছে। যেমন ধরুন, ওদের জ্ঞানটা কিন্তু একটা টাইম পর্যন্ত আপডেট করা থাকে, স্ট্যাটিক নলেজ যাকে বলে। তার লেটেস্ট তথ্যে সবসময় আপডেটেড নাও থাকতে পারে। আর ওরা না, সত্যি বলছি কিনা, তার চেয়ে বেশি চেষ্টা করে উত্তরটা যেন শুনতে ভালো লাগে, বেশ সাবলীল হয়। এর ফলে কি হয়, অনেক সময় ভুল তথ্য দেয় বা এমন কিছু বানিয়ে বলে যেটা সত্যিই না। এই যে হ্যালুসিনেশনের কথা শোনা যায় আর কি।
ও আচ্ছা, তার একদিকে যেমন কিছু চিন্তা করার মতো ব্যাপার আছে, অন্যদিকে কিন্তু সম্ভাবনার দিকটাও কম নয়, তাই তো? যেমন ধরুন, লিটারেচার রিভিউ করা কিংবা গবেষণার জন্য প্রশ্ন তৈরি করা, স্টিমুলাস ডিজাইন করা, এমনকি ডেটা সংগ্রহের জন্য AI ইন্টারভিউয়ার ব্যবহার করার কথাও তো আসছে।
হ্যাঁ, ডেটা কোডিং বা বিশ্লেষণেও সাহায্য নেওয়া যেতে পারে।
দারুণ তো। যেমন ধরুন, গবেষকরা যদি জানতে চান যে ক্রেতারা একটু অন্যরকম দেখতে কিন্তু ভালো সবজি, অনঅ্যাট্রাকটিভ প্রোডিউস নিয়ে কি ভাবছেন, সেক্ষেত্রে GenAI ব্যবহার করে হয়তো চটজলদি অনেক তথ্য একসাথে পেয়ে যাওয়া সম্ভব।
হ্যাঁ, সম্ভাবনাগুলো অবশ্যই অনেক, কিন্তু এই সুবিধার সাথেই ঝুঁকিগুলো জড়িয়ে আছে। যেমন লিটারেচার রিভিউ করতে গিয়ে দেখা গেল ভুলভাল সাইটেশন দিয়ে দিল। একটা উদাহরণ আছে, ডি হুগের পেপারের ক্ষেত্রে ভুল জার্নালের নাম দেওয়ার মতো ঘটনা ঘটেছে।
বলেন কি? এটা তো মারাত্মক ভুল।
ঠিক। আবার ধরুন, ডিজাইন পর্বে এমন একটা পরিমাপক বা স্কেল বানিয়ে দিল যা আসলে কাজেরই না, যা মাপার কথা তা মাপছেই না, ইনভ্যালিড আর কি। অথবা ধরুন, এক্সপেরিমেন্টে এমন কিছু মিশিয়ে দিল যা রেজাল্টকে ঘেটে দিল, কনফাউন্ড যাকে বলে। ওই যে আপেলের ছবি তৈরির উদাহরণটা আছে, অসুন্দর আপেল বানাতে গিয়ে পচা আপেলের ছবি বানিয়ে ফেলেছে, যেটা গবেষক চাননি।
আচ্ছা।
এমনকি ডেটা সংগ্রহের সময় AI ইন্টারভিউয়ার হয়তো স্ক্রিপ্ট থেকে সরে অন্য কথা বলছে, বা ডেটা বিশ্লেষণে ভুল স্ট্যাটিস্টিক্স দিচ্ছে, কোডিংয়ে গণ্ডগোল করছে।
তার এই ভুল সাইটেশন, ডিজাইনে গণ্ডগোল, এগুলো এড়ানোর জন্য আমাদের খুব সতর্ক থাকতে হবে।
এখানেই বোধহয় সবচেয়ে গুরুত্বপূর্ণ হয়ে ওঠে যে এই টুলগুলো আমরা কিভাবে ব্যবহার করছি, তাই না?
ঠিক তাই। এই কিভাবে ব্যবহার করা হচ্ছে সেটাই আসল। ঠিকঠাক প্রম্পট দেওয়া, নির্দেশটা ঠিকমতো দেওয়া। আর সবচেয়ে জরুরি হলো AI যা বানিয়ে দিচ্ছে সেটাকে খুব ভালোভাবে যাচাই করে নেওয়া। অন্ধভাবে বিশ্বাস করলে চলবে না।
ব্যবহারের রাস্তাও তো অনেক রকম হতে পারে। কেউ হয়তো সাধারণ ওয়েব ইন্টারফেস ব্যবহার করছেন, চ্যাট উইন্ডোতে। কেউ আবার API দিয়ে আরও কন্ট্রোলড উপায় ব্যবহার করছেন। কেউ বা লোকাল মেশিনে মডেল ইনস্টল করে নিচ্ছেন। প্রতিটারই সুবিধা অসুবিধা আছে। যেমন ধরুন, ডেটার প্রাইভেসি কতটা থাকছে, বা আপনার গবেষণার ফলাফলটা অন্য কেউ আবার করতে পারবে কিনা, রেপ্লিকেবিলিটি, এগুলো ভাবতে হবে।
আচ্ছা, ডেটা কোডিংয়ের ব্যাপারটা যদি একটু বুঝিয়ে বলেন। যখন GenAI দিয়ে ডেটা কোড করা হচ্ছে, তখন সেটার ভরসাযোগ্যতা বা ভ্যালিডিটি কিভাবে নিশ্চিত করা যায়?
খুব জরুরি প্রশ্ন এটা। ডেটা কোডিংয়ের ক্ষেত্রে যখন AI কোনো টেক্সট বা ইমেজকে লেবেল করছে, তখন ওই লেবেলিংটা আসলেই ঠিকঠাক হচ্ছে কিনা সেটা যাচাই করাটা মাস্ট। গবেষকদের আগে ঠিক করতে হবে তারা কি মাপতে চাইছেন। এটা কি অংশগ্রহণকারীর নিজের অনুভূতি, নাকি বাইরের কেউ পর্যবেক্ষণ করে যা দেখছে সেটা, নাকি কোনো বস্তুনিষ্ঠ আচরণ? সেই অনুযায়ী সঠিক ভ্যালিডেশন পদ্ধতি বাছতে হবে। যেমন ধরুন, কিছু ডেটা আলাদা করে সরিয়ে রেখে হোল্ড আউট ডেটা, সেটা দিয়ে এআই মডেলটাকে টেস্ট করা যেতে পারে, যা সে আগে দেখেনি। শুধু প্রম্পটটা দেখতে ভালো হলেই হবে না, আউটপুটটা আসলেই কাজের কিনা, ভ্যালিড কিনা, সেটা নিশ্চিত করা গবেষকের দায়িত্ব।
বেশ, তাহলে সবটা শুনে যা বোঝা গেল যে এআই নিঃসন্দেহে একটা শক্তিশালী হাতিয়ার হয়ে উঠছে গবেষকদের জন্য, কিন্তু এর ক্ষমতা আর সীমাবদ্ধতা দুটো সম্পর্কেই খুব পরিষ্কার ধারণা রাখা দরকার, আর খুব দায়িত্বের সাথে ব্যবহার করাটা ভীষণ জরুরি। অনেকটা ধারালো ছুরির মতো, তাই না? সাবধানে ব্যবহার না করলে কিন্তু বিপদ।
ঠিক। আর এখানেই কিন্তু একটা বড় প্রশ্ন চলে আসে ভবিষ্যতের জন্য। যখন এই টুলগুলো গবেষণার সঙ্গে আরও অঙ্গাঙ্গিভাবে জড়িয়ে যাবে, তখন আমরা গবেষকরা কিভাবে নিশ্চিত করব যে এগুলো আমাদের বৈজ্ঞানিক অনুসন্ধানের যে মানবিক দিকগুলো আছে, সমালোচনামূলক চিন্তাভাবনা, গভীর বিশ্লেষণ করার ক্ষমতা, নৈতিক বিচার বুদ্ধি, এগুলোকে আরও শক্তিশালী করে তুলছে, এগুলোকে ভোতা করে দিচ্ছে না তো? এটা কিন্তু আমাদের সবাইকে ভাবতে হবে।
অবশ্যই। এই আলোচনাটা আরও গভীরে গিয়ে বুঝতে হলে আর খুঁটিনাটি জানতে আমরা আবারও অনুরোধ করব মূল প্রবন্ধটা পড়ার জন্য। লিঙ্কটা শো নোটসে দেওয়া থাকছে। नमस्कार,
रिवाइज एंड रीसबमिट में आपका स्वागत है। मैं हूं पावलोव
और मैं हूं निकिता।
चर्चा शुरू करने से पहले एक जरूरी बात, ये जो बातचीत हम कर रहे हैं, ये असल में ब्लैंचर्ड और उनके सहयोगियों के लेख का सिर्फ एक लार्ज लैंग्वेज मॉडल यानी LLM से तैयार किया गया सारांश है। देखिए, गहन अध्ययन से जो समझ, सहानुभूति और मानवीय परख मिलती है, वो ऐसी चीजें हैं जिन्हें आप ऑप्टिमाइज नहीं कर सकते, उन्हें जीना पड़ता है। तो हमारी गुजारिश है, चाहे आप इस चैनल का सब्सक्राइब करें या नहीं, प्लीज प्रतिष्ठित जर्नल ऑफ मार्केटिंग में छपे इस मूल लेख को ध्यान से पढ़ने के लिए जरूर समय निकालें। लिंक आपको शो नोट्स में मिल जाएगा। तो आज हम ब्लैंचर्ड और उनके साथियों के रिसर्च पेपर को समझ रहे हैं। ये पेपर इस बात पर फोकस करता है कि चैट GPT जैसे जो जनरेटिव AI यानी GenAI टूल्स हैं, वो सर्वे और एक्सपेरिमेंट वाले रिसर्च को कैसे बदल रहे हैं।
हाँ, और इनमें पोटेंशियल तो बहुत दिखता है ना?
बिल्कुल, पर अगर बिना पूरी जानकारी का इनका इस्तेमाल किया तो कुछ रिस्क भी हैं। तो आइए इसी पर बात करते हैं। ये जो टूल्स हैं, ये रिसर्च के कई कामों में, जैसे लिटरेचर रिव्यू हो, स्टडी डिज़ाइन हो, या फिर डेटा कोडिंग और एनालिसिस, उसमें क्रांति ला रहे हैं। पर दिक्कत यह है कि कई रिसर्चर्स इन्हें इस्तेमाल तो कर रहे हैं, लेकिन शायद पूरी तरह समझे बिना कि भाई ये काम कैसे करते हैं अंदर से।
बिल्कुल सही। और समझने वाली बेसिक बात यह है कि LLMs असल में समझते नहीं हैं। वो दिए गए टेक्स्ट के आधार पर पैटर्न पहचानते हैं और अगला शब्द या टोकन क्या होगा इसका अंदाजा लगाते हैं। उन्हें बहुत बड़े डेटा सेट पे ट्रेन किया जाता है, पर उनका ज्ञान वो ट्रेनिंग पॉइंट पर ही रुक जाता है, अपडेट नहीं होता बाद में। और वो सटीकता से ज्यादा, भाषा सुनने में कितनी सही लग रही है, लिंग्विस्टिक प्लॉजिबिलिटी, उसको प्राथमिकता देते हैं। और यहीं पर उनकी एक बड़ी लिमिटेशन आ जाती है। वो ऐसी बातें बना सकते हैं जो सुनने में तो सही लगे, पर फैक्ट्स के हिसाब से गलत हो।
हाँ, और इस पेपर में एक अच्छा उदाहरण भी है लिटरेचर रिव्यू का, कि GNA रिलेटेड आर्टिकल्स ढूंढने में मदद तो कर सकता है, पर कभी कभी गलत जानकारी दे देता है। जैसे वो डेहोत इटाल वाले अध्ययन के लिए गलत जर्नल का नाम बता दिया।
हाँ बिल्कुल, वो RAG रिट्रीवल ऑगमेंटेड जनरेशन वाली तकनीक है।
हाँ।
मॉडल को बाहर की ताज़ा जानकारी से जोड़ना। हाँ। उससे कुछ मदद मिलती है, पर वो भी फुल प्रूफ नहीं है।
तो क्रॉस चेक करना, वेरीफाई करना बहुत ज्यादा जरूरी है।
बिल्कुल, एक्सट्रीमली इम्पोर्टेंट। और फिर जब बात आती है स्टडी डिजाइन की, जैसे सर्वे के सवाल बनाना या एक्सपेरिमेंट के लिए कंडीशंस तैयार करना, मान लीजिए आकर्षक बनाम अनाकर्षक सेब का वर्णन करना है, GNIS में हेल्पफुल हो सकता है, लेकिन अगर इंस्ट्रक्शन क्लियर न हो तो वो कॉन्सेप्ट्स को मिक्स कर सकता है। जैसे सेब वाले उदाहरण में AI ने आकर्षण और ताजगी को मिला दिया।
अच्छा, तो वो बारीकियां मिस हो सकती हैं।
हाँ, तो रिसर्चर्स को बहुत स्पेसिफिक होना पड़ेगा और जो आउटपुट आए उसे ध्यान से जांचना होगा ताकि कोई अनपेक्षित कंफाउंड्स ना आ जाए। कोई ऐसा छिपा हुआ फैक्टर जो नतीजों को गड़बड़ा दे, चाहे वो टेक्स्ट हो या AI से बनी तस्वीर।
ठीक है, तो डिजाइन में ये सावधानी रखनी होगी। अब अगर हम डेटा एनालिसिस और कोडिंग की बात करें, जैसे मान लीजिए इंटरव्यू ट्रांसक्रिप्ट को कोड करना है, तो क्या वहां भी ऐसे ही चैलेंज है?
हाँ, वहां भी है। जेआई टेक्स्ट रिस्पॉन्स को कोड करने में मदद कर सकता है, बिल्कुल। पेपर में अलग अलग तरीकों की बात है, जैसे एपीआई यूज़ करना या फाइल अपलोड करके कोड बनवाना। एपीआई वाला तरीका हर रिस्पॉन्स को अलग अलग प्रोसेस करता है। ये फ्लेक्सिबल है, पर क्योंकि ये संभाव्य है, प्रोबेबिलिस्टिक है, तो नतीजों में थोड़ा फर्क आ सकता है।
अच्छा।
और जो फाइल अपलोड वाला तरीका है, उसमें एआई अक्सर एक कस्टम डिक्शनरी बनाकर उसे लागू करता है। वो ज़्यादा ट्रांसपेरेंट है, पर शायद कम लचीला। लेकिन देखिए, मेन बात यह है कि सिर्फ प्रॉम्प्ट सही लग रहा है, इसका मतलब ये नहीं कि आउटपुट पर भरोसा कर लिया जाए।
तो आप कह रही हैं कि एक ही प्रॉम्प्ट से भी अलग अलग नतीजे आ सकते हैं।
ये तो एनालिसिस में गड़बड़ कर सकता है। फिर रिसर्चर कैसे भरोसा करे? वैलिडेशन कैसे हो?
एग्जैक्टली। यहीं पर कठोर वैलिडेशन मतलब सख्त जांच की जरूरत पड़ती है। आपको जेएनआई की कोडिंग की तुलना ह्यूमन कोडिंग से करनी होगी या दूसरे मेजरमेंट से। ये इस पर डिपेंड करेगा कि आप मापना क्या चाह रहे हैं। पार्टिसिपेंट का नजरिया, किसी बाहरी ऑब्जर्वर का मूल्यांकन या कोई ऑब्जेक्टिव नतीजा। पेपर इसके लिए कुछ स्पेसिफिक वैलिडेशन स्ट्रैटेजीज भी बताता है। सच कहें तो इन नए उपकरणों के लिए वाकई नए नियमों की जरूरत है। तो संक्षेप में कहीं तो इस पेपर का निचोड़ ये है कि जेएनआई रिसर्चर्स के लिए एक बहुत पावरफुल असिस्टेंट है, पर इसका जिम्मेदारी से इस्तेमाल करने के लिए यह समझना जरूरी है कि यह काम कैसे करता है, इसकी सीमाएं क्या हैं, और हर स्टेप पर, हर कदम पर इसके आउटपुट को सख्ती से जांचना होगा। आंख बंद करके भरोसा नहीं करना।
हाँ, क्रिटिकल एंगेजमेंट चाहिए।
बिल्कुल।
और एक बात और सोचने वाली है आगे के लिए। जैसे जैसे ये टूल्स हमारे काम में और ज़्यादा इंटीग्रेट होते जाएंगे, रिसर्चर्स ये कैसे पक्का करेंगे कि ये असल समझ और साइंटिफिक रिगर को बढ़ाने में मदद करें, उसे कमज़ोर न करें। वो जो बारीक लाइन है कुशल मदद और ज़रूरत से ज़्यादा निर्भरता के बीच, वो कहाँ है?
ये वाकई एक अहम सवाल है जिस पर सोचना होगा। इस विषय की और गहरी समझ के लिए हम श्रोताओं को फिर से याद दिलाना चाहेंगे कि मूल शोध पत्र जरूर पढ़ें। लिंक शो नोट्स में है। आज की चर्चा यहीं समाप्त करते हैं।